Okay, so this is session 1B. The username is ALG1. The password is Teach2025. So this session, we do have a calculator for session 1B, which is great. We're going to click on 1B, click through all these other things here to begin the test. Okay, so now that we're in the calculator session, we have a couple extra buttons. We have this button, which is the scientific calculator, and this button here, which is our graphing calculator, Desmos. In question number 9, it says an absolute value function in the form f of x equals a times the absolute value of the sum of x and b plus c is graphed in the xy coordinate plane. It says to choose graph the function, and it gives us a function in the coordinate plane. So first thing we're going to do is open that one in Desmos. So we're going to type it in just like we see it, f of x equals. If you've forgotten where the absolute value symbol is, when you pull up on the keyboard, right above the big ABC shift button is the absolute value brackets. So make sure you type the negative first, then the absolute value brackets, 2x minus 6. Close the bracket by arrowing over and then put a plus 1. So what this has done is it has graphed this for me. But I need to put this graph into my answer box. And this is something you'll have to be careful about following the directions, because some people put multiple points and it's going to mark it wrong. You have to read these directions on the side. It says in order to graph this on here, we're going to select the point button in the graph, click where we want our vertex to be. The vertex is where it changes directions. It's either the max or min. So I'm going to click on this point and go to 3, 1 and put that point. That's the only point I put on the graph. We're using other points to know where to put the rays, but we only click a point on the vertex because that's what it says here. This next step is to select the ray button, click from the vertex and drag it to where you want it to be. I'm going to do the left side first. So I'm going to select the line, the little ray, solid line extension. I'm going to click on the vertex and I want to go to 0, -5. Right there, when I release the button, it draws my line.
Wait, how you do the line thing then?
You click, so after you have the point, you click this ray button, hold your mouse button down,
Oh, I see.
and then drag it to 0, -5.
I can't see.
On the right side of it, that we need to go through the ordered pairs 6, -5. So once again, I still have that ray selected. Click on the vertex and go over to 6, -5. Release it, and it should look exactly the same as this.
I don't know how to do it.
If you need help, just let me know. No, right there. Okay, so what you're doing, and y'all, so everyone should have the Desmos opened on their screen. Leave it open. Remember, I'm checking everyone's computers to make sure you do it. So first start by going to Desmos.
Shut up, David.
Put it back in.
Shut up.
Yes, enter it back in.
It's all in the one. How am I supposed to drop when it doesn't?
What?
Okay, let's go back to the start because I don't think a lot of y'all were with me. I'm going to explain it one more time on this graph. Please pay attention. Once we have this in Desmos, it says to graph this on this grid over here on the test, on the practice test, select the point button. That's this one here, the dot. I'm going to click on it. Then it says on the graph, click where you want the vertex to be. The vertex should be at 3, 1. So I'm gonna go over to 3, up 1, and put the dot right there. That's the only dot I'm putting. The second bullet says, select the ray button, click on the vertex of the absolute value function, and drag the ray to the desired direction and repeat for the other side. So I'm gonna go to the ray button, up here, the line type, click on solid line. I go back to the vertex, hold my mouse button down, and I see the point that it needs to go through. Its y-intercept is at 0, -5. So I go to 0, -5, and then release the mouse button so it draws the line. To get the right side, if you look in your Desmos, the right side is going through the point 6, -5. So I'm gonna go back to that vertex, click down on my mouse, go to the 6, -5, release it.
I did it.
Keep that on your screen. I'm gonna come around and check just to make sure everybody has it good. Keep your Desmos open until after I've checked it, okay? Keep that Desmos open, because I wanna see that y'all are actually doing it in Desmos and not just copying from the screen. I wanna make sure everybody knows how to do all of these things in Desmos. Type it in,
Wait,
Desmos,
what do I type in?
what you see right here.
So,
And I don't know, is it possible to, like copy paste? I'm really not sure. No, it doesn't let you do that. So you do have to type it. So when you're in Desmos for typing it, to find the absolute value bars, you pull up the keyboard and it's right there above the ABC.
wait, mine doesn't show that.
You're typing in everything you see. F of X
How you put that line though?
right here.
Oh,
Above the ABC button is your absolute value braces or brackets, lines, whatever, vertical lines.
I did not know that was out.
So that should be on everybody's screen. Good? Remember, do not close the Desmos till after I've checked your Chromebooks. Okay, looks like everybody got it. Let's go to the next question, question number 10. Question number 10, we actually have a little bit of writing we need to do. So I'm gonna have to,
Oh yeah.
because the writing won't record on the video unless I go to the Promethean chart, I'm gonna do the writing here. You'll write it on your paper, but I'm also gonna have this minimized so we can split screen so we can look at both, okay? It says that Leah would like to earn at least $120 per month. She babysits for $5 an hour and works at an ice cream shop for $8 an hour. Leah cannot work more than a total of 20 hours per month. Let X represent the number of hours she babysits and Y is the number of hours she works at the ice cream stand. Question for part A says which graph shows the set of points that represents the number of hours she can work in order to satisfy both of these conditions. So we're looking at a system of inequalities. When you've got two lines, it's called a system or two graphs. And we want to see, we have to first set up the inequalities and then we want to see which graphs match it. So they've already defined our variables for us, which is that first step that we used to do. So I know that X represents babysitting, Y is representing ice cream hours, okay? It tells me that she can only work 20 hours. So the number of babysitting hours plus the number of ice cream hours has to be, if she can only work 20, her amount has to be less than or equal to 20. So that is the first inequality for what we're doing here, okay? And in a minute, once we get this part written, I'm gonna go back to this screen and put it in Desmos, okay? So we can check the answer. The second equation is talking about how much money she's making now. If she's making, God bless you, $5 an hour for babysitting, think about if you work 3 hours and you're making $5 an hour, how much money do you make? You multiply that, right? So 5 times however many babysitting hours plus $8 an hour for however many ice cream shop hours. And she wants to earn at least $120. That means her amount should be greater than or equal to $120. So now we're gonna go to our online practice test and select the graphing tool and enter the two inequalities that we just created. Remember, if you can't get to the, in order to get to those inequality symbols, you have to pull up on this keyboard. We want this amount to be less than or equal to 20.
That's a Y?
Yes, x plus y is less than or equal to 20.
Oh, I thought it was 200.
And then in this second line, we're gonna be putting the money part of it, which was 5x plus 8y, and this amount should be greater than or equal to $120. I'm trying to see which of these graphs match this. Remember, for a system of inequalities, the graph, the solution part of the graph is where the two colors are overlapping. That's the solutions to all of this. So I can see just from looking at this that it's not gonna be A or C. So if you want to, you can use the cross-off tool, that's up to you, but it is a resource that's available to you. Now to find which one of these works, I'm looking at some important points, and I'm gonna choose these y-intercepts. My top line should be going through 20, the bottom line through 15. So that means it's not B, it's gonna be D. So I need to see this on your screen, so make sure you've got that on your screen right now, your Desmos and your answer checks. And you should have written those inequalities, that system of inequalities on your paper. Good. Candace, I'm gonna come back to you. One turn, just turn a little bit, it makes it so much easier for me. So where's put it in Desmos. Good. Candace, you got it? Awesome. Part B, which is our next question, also goes with the same scenario. We actually have a part B, C, and D for this question. Once you move to the next question though, it automatically closes out your Desmos. So we're gonna have to retype this a few times. To save time, I'm gonna take the bigger inequality and just copy it so that I can paste it when I get to the next question, okay? So we've got this first, part A done. Let's arrow over to part B. Part B says, which pair, the XY coordinates, represents hours that she could work and meet those given conditions. So what we're looking for is which of these points fall in my solution area. So I'm gonna do that inequality system again. X plus y should be less than or equal to 20. And then the second one was 5x plus 8y is greater than or equal to 120. Keep in mind, the reason the original graph only showed the first quadrant is because we're talking about the amount of hours worked and money earned. It's only gonna give us positive solutions. You can't work in negative hours or earn negative money. All right, so to check to see which of these ordered pairs work, we're gonna type each ordered pair in, and I want you to leave them all in there until I check your Chromebook. I'm gonna start with the one that's at 15, sorry. I do see that that is in fact in my solution, so I select that as a correct answer. Go down to our next line, let's try 512. And see if that is part of my solution. It is in fact within the solution area, so I select that one again. Next point is at 10.9. That one is also in my solution, so that's A, B, and C are right already. Let's try D, which is at 15.5. When I look at 15.5, you may have to move your graph around. 15.5 is only working for that top inequality, but it's not a solution of both, so that would not be a right answer. And then the last one, which is at 19.1, is also not a correct answer because it shows up way down there. So the A, B, and C is the right ones, the rest of them are wrong. Y'all should have that in the graphing tool online to check yourselves. Good. Good.
Listen,
Yes, good, good, good. Where's your shade? You're doing the equal sign, that's your problem. It's the inequality symbols. Because you're looking for that shaded region, okay?
midday.
Y'all got it? Good, awesome. Okay, everybody's good with this one. Let's go to part C of this question. Once again, we still need this graph. So I'm gonna start by just putting that same system back in here. The x plus y is less than or equal to 20, and then the 5x plus 8y is greater than or equal to 120. All right, part C says, if Leah babysits for 7 hours this month, what is the minimum number of hours she would have to work at the ice cream shop to still earn $120? So first, let's think about which variable is representing her hours of babysitting. That is the x. And if x is 7, I'm going to type in this little graphing tool, x equals 7, to see where that lies in my solution zone. Okay? It's asking for the minimum number of hours. Minimum would be the lower y value. I see it's at 10.625, but it says to give your answer to the nearest whole hour. If we rounded down to 10, we would not be in the solution, so we're going to round up to 11 hours. Part D is saying Leah prefers babysitting. So she likes the X, have more X hours than Y hours if possible, or the most amount of X hours that she could. Out of the total 20 hours, what is the maximum number of hours that she can babysit and still earn enough money? So I'm looking at my X axis. What is the highest X value that I can go to? This is at 13.3, but again, I have to go to the nearest whole hour. If I go up to 14, I'm not going to be outside of that solution zone. So this one I round down to 13 hours. So remember, y'all should be writing this on the paper. There's some that you won't need to write on the paper because it's a lot of typing. What's wrong? Yeah. Less than. Yeah, there you go.
Wait, how do you get 11?
Then I did x equals 7. And I looked here and saw the x equals 7. The minimum value was 10.6 hours of ice cream, but we rounded it up to 11. All right, so is everybody good with part C and D of this question?
Yes.
Let's arrow to number 11. For this one, I'm gonna have to go back to that flip chart just because I have to, this one is not a Desmos one, this is a writing one. All right, for this equation, ax plus c equals bx plus d, blah, 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 solve for x. So all we're gonna be doing is rearranging this equation so that we can get the x isolated. Don't let the fact that these are all variables throw you off. It's the same process as if we were solving a line like 2x plus 3 equals 5. We want all our x's on the same side. So I'm going to start by moving this bx over by subtracting it on both sides. So I have ax minus bx plus this c equals to d. Y'all should be writing this. I have both my x's on the left, but I need to get rid of this constant c. So I'm going to subtract c on both sides. So I'm left with ax minus bx equals d minus c. My x is currently a factor of both of these parts, so I'm going to factor it out. We're undistributing, basically. When I take this x out, what is left behind is a minus b, because these x's will cancel to give me just one. And I still have the equals d minus c. What's happening to x? It's being multiplied by a minus b. To solve for x, I do the opposite. Divide both sides by a minus b. That cancels out, so we end up with x equals d minus c over a minus b. On your online practice test, what you're going to enter there, it's a drag and drop. So you drag the d minus c to the top box, drag the a minus b to the bottom box. And make sure you have all that written so you remember how we solve that answer. I've got all that written. Good. Let's go to question 12. Question 12, I'm also going to be writing, so I'm just going to go back to the flip chart for now, because that's the only way the video will record it. Number 12 says a worker earned a 2% increase in her annual salary for each of 4 years. She plans to continue working in her position for an additional N years. If she continues to earn a 2% increase each year, which statement describes the expression that can be used to calculate the total percent increase in her salary from the first year to the last year? So first of all, I want you to understand where this 1.02 is coming from, okay? She gets 100% of her salary, which is an equivalent as a decimal to 1.00. Y'all remember percent, to get it as a decimal, you move the decimal point over 2 places. A 2% is going to be 0.02 as a decimal. And since what she's getting each year is 100% of her current salary plus an increase of 2%, that's where the 1.02 is coming from in all of these expressions. Okay? Now it says that she gets this for 4 years, then gets it an additional N years. So if I'm looking at the equations that are here, an additional N would be adding N. So these two we can cross out. Now I just need to see which one of these reasonings is correct at the end. Is our exponent rule saying that when we multiply a common base, we add the exponents, or is it saying when we add a common base, we add the exponents? Think back to when we did things like x squared. If I did x squared times x cubed, do y'all remember our shortcut?
Yeah.
We add the exponents, right? So when it's being multiplied is when we add, which will make C our correct answer. So I'm going to choose C, and y'all should have that written on your paper. Once you have that written, choose the C, and then you can go to the next problem. And just to remind y'all, the reason I am walking around and making sure everybody has it written is because I'm going to give y'all a participation grade, easy, like 20 out of 20, so that for doing all of these. But I need to make sure everybody actually is. All right, we're good? Let's go to question 12. Question 12. So in session 1, this practice test has 2 constructive response. Remember, these practice tests is giving you an idea of what the real leap's gonna look like. It'll have different types of problems, but the actual setup of it, 8 questions for session 1, A, you know, without the calculator, all of that's gonna be what the leap looks like. All right, for question 13, 2 real numbers are defined as this. The A is 0.4, repeating. These dots at the end mean that pattern continues. Something like this can be written as a repeating decimal using that line up at the top, okay? This won't show up on the video, but I'm just gonna show you. This would be 0.4 with a line on top. That's what the repeating bar does. It says you're repeating that same thing. For B, it's 354, then 3554, then 35554. So that's not repeating the same thing over and over. Okay? So, determine whether each number is rational or irrational, and then decide if the product of A and B is rational or irrational. So let's start with term A. So y'all are going to type this, and I'm going to zoom it in for you to type this. So term A, is it rational or irrational? Do y'all remember the difference?
Irrational is
Right, okay. So rational numbers are numbers that can be written as a fraction, which includes terminating and repeating decimals. Irrational is not repeating a pattern, goes on forever. Typically, an irrational number, when you're seeing it on the paper, it's going to look like it has the pi symbol or a square root that's not a perfect square. So term A, because it is a repeating decimal, so term A is a repeating decimal, so it is rational. Our next term B is not repeating or terminating or ending, so it is irrational. So the first part said determine whether each one is rational or irrational. We've already done that. Now we have to decide if the product, if I multiplied A times B, if it would be rational or irrational. So the other day we looked at that problem where it was asking about rational and irrational numbers, and I said you could just pick numbers. So we had chosen 5 and square root of 2, right? So think about if I were to multiply 5 times the square root of 2, it would just be 5 square root of 2, which would still be irrational. So by definition, a rational number times an irrational number is always irrational. It's always going to work that way. So this should be typed in your box on your paper. You can shorten this. Maybe just write yourself a note. Rational is terminating or repeating. Irrational is not. You may even want to write irrational looks like pi or square root of a non-perfect square like square root of 2, square root of 5. Those are all irrational. So type it in the box and then write yourself some notes. Get focused. You have stuff to do.
Yeah, man.
We're doing 2 of these?
We're going to go as far as we can go. The goal is to get to problem number 20
What?
today.
Too much.
Look, we're getting pretty close.
Is that on?
Huh?
What they have on that?
Today is Salisbury steak, mashed potatoes.
Oh my God, I don't like that, bro.
Tomorrow is
This week
chicken
is
and chicken nuggets and waffles. Friday's cheeseburger.
Oh, I love cheeseburger.
Yeah, cheeseburger is the best. But
Really?
No,
You
it's
gotta wait
not.
all week for it.
They're like,
Why they put cheese
What's
on my
the best
burger,
one?
man?
I like the baked chicken and the rice are the nachos.
Wait. It's like the words.
The baked chicken is good.
No, it's not.
Okay,
The baked chicken, you can.
Oh wait,
one
I
bite.
did not put.
all right. Once you finish typing that in and writing some notes, you don't have to write word for word, but just get yourself some notes to remind you what rational and irrational is. And then you can arrow over to the next question, which would be question 14. 14 is a very fun, real world type of problem. And I know that my very first question I asked after I just say this, that Tristan's gonna have the answer for me. Well, a lot of you would. You'll see in a minute. All right, raise your hand if you need more time on the screen. Good.
Boom, I answered the question.
Hold, yeah, that was one of the questions, but it wasn't the actual one I was thinking, that I was fixing to ask you. So when we go to number 14, it says that Gabriel operates a riverboat and frequently offers tours of the river. Typically, a tour lasts 3.25 hours. The riverboat usually takes 2 hours to go 25 miles upstream, but it only takes 1.25 hours to make the 25-mile return trip. Tell me why.
Is it a current?
The current. When this boat is going upstream, it's going against the current. The water is pushing it back the other direction, so it takes longer. When it comes downstream, that current is behind it, pushing it, makes it go faster. This is very similar to a science type of question, yes.
Do we have science league?
Biology you'll have next year.
Oh, next year.
Uh-huh.
I hate science.
Okay, moving on. Now, so this is the situation that he's currently doing. The question is asking, it says he's considering offering a shorter tour that's only 2.5 hours and goes only 20 miles upstream before returning. Will the shorter tour be possible if the riverboat uses the same speed as it does in the original tour? Show your steps and justify your answer. For this one, I am going to be writing some, but also typing in some, because I feel like you need to actually see it written as well. So let's go to our flip chart for this one, and then we'll go back in and type some notes in. Okay. You should have, by now, middle school, between math and science, and I know we've even talked about it in here, you should know that there's a formula. The distance is the rate times time. What that means, rate is talking about your speed, okay? So rate is your speed. Think about this for a second. If you're traveling 50 miles an hour and you drive 3 hours, how far did you go?
Well, can you repeat that again?
Actually,
You're going 50 miles an hour. You drive for 3 hours. How far did you go?
150.
Yes. So that's what this means. This R times T means your speed, 50 miles an hour, times the time, 3 hours, gives you your distance. Okay? So now we're just going to go back to this. We're going to work all of this on the practice test because I need to make sure y'all are okay with what needs to be put in here to justify your answers. So first thing I want to tell you is it's scored by a rubric, and the way the rubric works is it's looking for a certain key things, but what it says in the rubric is you get like a 3 out of 3 if you have everything right. If you only have 2 of the 3 elements, you'll get a 2 out of 3. So my point is this. Write whatever it is you do, even if you don't know what you're doing, like write as much as you can about the situation and do even parts of it if you could. You get partial credit for whatever you put in, okay? So here's what we're gonna put in the box, and I am gonna blow it up again so y'all can see.
Oh, no.
Yeah, I mean, zoom in, yeah. All right, so we are using, and I'm just gonna type this formula out, distance equals rate times, actually, let's put an X for that time. After this, I'm just gonna use the D and the R and the T. I don't need to write that word out every time. But I started out telling everyone this is what my variables are meaning if I use them. Okay. In order to determine if the new tour is possible, knowing that the new tour is using the same speed, I need to find out how fast the boat was originally going. Okay, so the original tour, upstream, I'm going to use what I know about the information to figure out the speed. So it tells me in this problem that it took 2 hours to go 25 miles. The distance is 25, so I'll do 25 equals 2 hours is my time, but I don't know my speed or my rate. So I'm going to put 25 equals 2R. That's my first equation. On paper, if we were solving this, think about what you would do to get the R alone. R is being multiplied by 2, so what we would do is divide both sides by 2. I need to show that or say in words, divide both sides by 2. If you want to just show it, you would type 25 over 2 equals 2R over 2. That is showing that we're dividing both sides by 2. This is the calculator session, so I can open my calculator to do that division. But what you end up finding out is that 12.5 equals R. So I know how fast it's going. So in other words, the boat goes 12.5 miles per hour. MPH, everybody pretty much knows what it means. You don't have to spell it out. Okay? 12.5 miles per hour upstream. Now let's look at the original tour downstream. On the way back, now he's gone 25 miles from dock, so the trip back is also 25 miles, but it said that it only took 1.25 hours, so that 25 is going to equal 1.25 times whatever my speed is. Just like before, if I'm solving for the rate, I would divide both sides by the coefficient, the number in front of that variable R. So both sides will be divided by 1.25. It comes out to be exactly 20, yes. When you use the calculator and divide 25 by 1.25, you get the answer is 20 equals the rate. So what does that mean? The boat goes or travels 20 miles per hour downstream. For this problem, since we're typing it all in here, I'm not going to make you also write it. That just takes too much time. But remember, these videos will be available in your Google Classroom. So feel free, go look at it before, look back over it if you want to look at what you didn't get written on your paper. All right, so now the new trip. The new trip, he's going 20 miles. So I know my distance is 20. His speed or rate upstream, let me do new trip upstream. Let's add that in there. Upstream is 20 equals, my speed was 12.5, and I don't know the time that it's taking. That's what I'm trying to figure out. How long is it going to take him to do this? To solve for t, the opposite of multiplying by 12.5 is divide both sides by 12.5. You can use the calculator to do that division. 20 divided by 12.5 is 1.6 is the time, okay? So the new trip takes 1.6 hours upstream. Let's now look at the new trips downstream. All right, downstream, we're still going 20 miles on our new trip, so it'll be 20 equals. The speed downstream was 20 miles per hour, and again, I need to figure out the time. So each time I've put substituted values in place of those variables, but I still have a variable in there that I need to solve for. Just like before, if I'm trying to solve for t, since t is being multiplied by 20, I'm going to divide both sides by 20. And this one is really simple. I get that it's 1. 20 divided by 20 is 1. So 1 is the time. What that means is new trip downstream takes 1 hour. The total new trip using these speeds would take, add that together, 1.6 plus 1 is 2.6 hours. The question asked, can he do this trip in 2.5 hours? So the answer is no. And I'll put the new trip would take 2.6 hours, which is more than 2.5, comma, so he cannot offer this tour. He could offer the tour if he chose to change the speeds. So the reason he can't do it in this time is because he wanted the speeds to still be the same. Maybe that's the fastest his boat goes. I don't know.
You need to get him a bigger boat.
He needs a bigger, better boat.
He needs a way bigger boat.
And you know, if you think about this in the real world, it makes sense to start out going upstream and take longer, because if you're on a river tour, you're going slower to look at things.
Are we done?
Right.
We're done with this problem.
Dang.
We're not done for the day though.
Oh.
All right, so that's the end of session 1B.